and word difference representations for language modeling, proposes a novel framework for causal language modeling, CLM, that incorporates n-gram prediction and word difference representations. Let's start with the basics. What are the limitations of traditional CLM approaches?
Traditional CLM approaches, which predict the next word in a sequence, often struggle with capturing long-term dependencies between words. They tend to focus on local dependencies, which can lead to overfitting and a lack of generalization.
So how does this paper address these limitations?
The paper introduces a simple n-gram prediction framework for CLM. Instead of predicting only the next word, the model predicts multiple future words, effectively capturing longer-range dependencies.
That's interesting. How does the model actually predict these n-grams?
The model uses an additional multi-layer perceptron, MLP layer, for each future word prediction. This MLP layer takes the encoded hidden state from the CLM model as input and outputs the predicted word embedding for the future word.
So the model is essentially learning to predict multiple words simultaneously. But how does this help with capturing long-term dependencies?
By predicting multiple future words, the model is forced to consider the context beyond the immediate preceding words. This encourages the model to learn more global dependencies within the sentence.
That makes sense. But how does the paper further enhance this anagram prediction framework?
The paper introduces a novel concept called word difference representation, WDR. Instead of using the original word embeddings as targets for prediction, the model learns to predict the difference between consecutive word embeddings.
Why is this difference representation beneficial?
WDR provides a more contextualized and diverse representation of words. The difference between two consecutive words captures the relationship between them, which can be more informative than the individual word embeddings themselves.
So the model is essentially learning to predict the contextual shift between words. How does this affect the training process?
By using WDR as the target, the model receives more diverse and contextualized training signals. This can lead to improved generalization and a better understanding of the relationships between words.
That's fascinating. Does the paper also propose any methods for combining these n-gram predictions?
Yes, the paper proposes an ensemble method that combines the predictions from the n-gram model with the original CLM prediction. This ensemble approach allows the model to leverage the information from multiple future word predictions to refine the final prediction.
So the model is essentially taking a weighted average of the predictions from different time steps. How does this affect the overall performance?
The ensemble method generally improves the performance of the model, especially on smaller datasets. This suggests that the information from the n-gram predictions can be valuable for improving the accuracy of the final prediction.
The paper also mentions an analysis of gradient diversity. Can you explain what that is and how it relates to the WDR method?
Gradient diversity measures the variability of gradients during training. The WDR method, due to its diverse target representations, tends to produce higher gradient diversity compared to traditional CLM approaches.
And why is higher gradient diversity beneficial?
Higher gradient diversity can lead to improved generalization, as it encourages the model to explore a wider range of parameter space during training.
To wrap up, can you summarize the key contributions of this paper?
The paper proposes a novel n-gram prediction framework for CLM that incorporates word difference representations. This framework improves the ability of the model to capture long-term dependencies and leads to better generalization. The paper also introduces an ensemble method that further enhances the performance of the model.
This was a great discussion on the technical aspects of this paper. Thank you for your insights.